This is the first map of the Milky Way made by William Herschel back in 1785 in a paper he called On the Construction of the Heavens. And it's a wonderful thing, but it's not that accurate. It shows the sun at the centre, which is wrong. There are no spiral arms. But he did get one important thing right. He shows the Milky Way as a disk seen almost side on.
Since then, our knowledge of the Milky Way has greatly improved. But these images are actually artists' impressions. We think that the Milky Way looks like this, but we don't know for certain. In fact, we know surprisingly little about our home galaxy.
But a revolution in our understanding of the Milky Way is underway. And the more we learn about our galaxy, the more surprising and interesting it becomes.
So tonight, we bring you the bang up-to-date guide to our galaxy with the most exciting and unusual discoveries.
Welcome to the Sky at Night.
Like all good guides, ours will include the best maps available, the most interesting destinations, and of course, a bit of history.
We're down.
We'll be joined by guest presenter Neil deGrasse Tyson for a tour of his top 5 strange and spectacular stars.
This white dwarf is effectively flaying the outer layers of this giant, consuming it, body and soul.
Pete will show us how to find some of the highlights of our galaxy in the night sky. But first, we're going to start with the most essential part of any guide, the map.
We're here at the Institute of Astronomy in Cambridge, where the researchers have been making the most detailed and the most accurate map of the Milky Way ever. To do that, they're using one of the most impressive space telescopes ever constructed. If it were here on Earth, it would be capable of measuring the thickness of a coin on the moon.
In December 2013, the European Space Agency launched the Gaia Space Telescope. Its mission, to map the stars of the Milky Way in unprecedented detail. Gaia is actually 2 telescopes, each observing 100,000 stars per hour, and capturing the data with a 1 billion pixel camera, giving Gaia a resolution that is 10 times greater than most ground-based telescopes. Over its 5-year mission, Gaia will observe each part of the sky 70 times in order to measure the exact positions of the stars, their distances, and their motions. This room is where data from Gaia comes pouring in and gets processed. It's effectively the nerve center for understanding our galaxy. You get some idea of the scale of the data processing operation in here. This supercomputer is made up of 1,296 processing cores. But this is just the tip of the iceberg. There are 5 more centers like this dotted around Europe, all handling Gaia's data. To convert raw satellite data from Gaia into an actual map of the Milky Way with precise positions, distances, and brightnesses is no mean feat. In fact, for the first batch alone, they've had to analyze around 120 billion images. And to achieve the incredible precision required by the Gaia mission, the data processing teams have to try to correct for every possible source of error. They even have to account for the gravitational influence of the other planets in the solar system on the light from the stars. It's a tremendous task, so much so that it took a year to process the first 14 months' worth of data. But it's been worth all the effort, because the result is nothing less than the first truly accurate map of our home galaxy. And Chris went to meet lead scientist Jerry Gilmore to see the map for himself.
So, Chris, welcome to our new map of our Milky Way.
It's beautiful.
You see immediately the sort of big picture structure. First thing to notice is that this is a map of the entire sky.
But this stripe across the middle, this bright stripe, that's the galaxy.
That's the Milky Way galaxy, that's right, yes.
But there is more to the Milky Way than just the main disk. There are also millions of stars both above and below the disk. Everything white that you can see in this image is starlight.
What we need to do is zoom in. So this is the top layer map, and now we're zooming in. So this is the inner parts of the Milky Way here, these big dust clouds and dust lanes, the dust lane. These are dust lanes, and you start to see that all the white light is now breaking up into stars, into individual stars.
As you get further in, as we zoom in, we see more and more stars individually.
Absolutely. Look at how they suddenly appear as you go that little bit deeper into space, and ping, what you thought was just white light is actually starlight.
And how many stars are there in the galaxy?
There's maybe 100 billion, 200 billion, 300 billion. The number's probably near the high end of that range. What we know is that there's maybe twice as many as we previously thought.
There are twice as many stars in the galaxy as we thought.
That's right. Yeah, it's just in the bit of the Milky Way that Gaia has measured. There are twice as many stars in there.
How has Gaia doubled the number? That seems surprising to me. I assumed that you didn't know the position before, but where have they been hiding?
It's just because of the image quality of Gaia, the fact that Gaia has such high spatial resolution.
Because it can see sharply.
Exactly, it sees sharply, and so Gaia can tell the difference between 2 or 3 stars that are very close together, but nevertheless are separate stars, whereas previously, from our images from the ground, blurry sort of things, this stuff here would have all been merged into what we thought was one star.
And so we've been looking at the map as it appears on the sky, but one of the exciting things about Gaia is that we have 3-dimensional information as well. We can go beyond this sort of 2-dimensional picture.
Exactly, and that's the unique feature of Gaia. Gaia measures distances as well as all these other things. And once we get into measuring distances, then we can measure the 3-dimensional structure of our Milky Way. So far, we've only just had a taster of that. So Gaia's just released 2 million accurate distances. And so here is the beginnings of a picture in 3 dimensions. This is our sun. And we're about to go and see the Hyades and the Pleiades cluster.
Nice part of the autumn sky. Yeah. Oh, look, there's Betelgeuse and the Hyades there with Aldebaran in front of them, the Pleiades in the corner. There goes Aldebaran, it's closer to us.
And so here we are, for the first time ever, seeing a star cluster in 3 dimensions. So we can tell the difference between the front side and the back side of the Hyades. So we know exactly in 3D where all these stars are.
And this helps understand the cluster. We know more about it than we did before we had this map.
And so we have already discovered not only how deep the Hyades cluster itself is, but actually it's about twice as big.
It's amazing. What other features should we look for in this 3D map?
So this dramatic Hyades example, one very nearby cluster, is just a taster for what's going on. We've got good distances now for just 2 million stars. We're going to have 1 billion at least. That will give us a 3-dimensional map of half of our Milky Way. But even more interestingly, because Gaia's continuing to observe over time, it's telling us how everything's moving. And that combination of where things are and how they're moving allows us to determine how the galaxy works as a machine, how the Milky Way actually functions, what is the spiral arm, where is the dark matter, and how it's evolving.
Well, it's going to be very exciting.
Going to be fantastic.
So now we have a map of over 1 billion stars in our galactic guide. But the question is, where do we go and visit? What are the most interesting and exciting stars within our galaxy? We invited astrophysicist Neil deGrasse Tyson, who has written about this very subject in his book, Welcome to the Universe, to give us a guide to the weird and wonderful stars of the Milky Way.
The sun. It's 1 million times bigger than the Earth. It's widely regarded as a yellow orb in the sky, but it's actually white. You know, our sun is not the hottest or the coolest or the biggest or the smallest. There's nothing to distinguish it among the hundreds of billions of other stars in the galaxy. In fact, if you were an intergalactic alien and you came upon the Milky Way, there'd be nothing about our star system that would attract your attention. But there's plenty of other stars in our galaxy worth a look. And I've made a personal list of the top 5. Coming in at number 5 of our exotic star countdown of the Milky Way is SAO 206462. Previously thought to just be an ordinary star, when you go in and look close and you blot away the light of this relatively new star that was just formed, you get to see this remarkable spiral structure. We're pretty confident that this is a disk of debris in the act of forming brand new planets around this relatively newly born star. Each of these spiral arms will likely coalesce and, in the not so distant future, become single planets, one for each arm, in mutual orbit around the host star. We've seen disks of material before around newborn stars, hinting that planets are soon to form. But this is the first time we've ever seen spiral structure. This star is just at the beginning of its life, and who knows what other strange phenomena it will treat us to as it evolves. But strange behavior isn't the preserve of the young. Coming in at number 4 among the top 5 weirdest stars in the Milky Way galaxy is Omicron Ceti. Ceti referencing the constellation Cetus, the whale. Here it is. It happens to be a red giant star. Plenty of these in the galaxy. Not even distinguished for how it looks in visible light. But if you instead observe this star using ultraviolet, this is what you find. The star is up here, and there's this long 13 light year plume left behind. And right up front, we have a bow shock, which is evidence that this thing is plowing through the galaxy between the stars at incredible speeds. In fact, we can measure it at 300,000 miles an hour. We happen to know that red giants only have a tenuous connection to their outer gaseous shells. So going that fast, it's going to lose some of that outer shell, leaving it behind as it punches its way through the gas of the interstellar medium. We've never seen anything like this. But the most spectacular sights to be seen don't just involve one star. Coming in at number 3 is MY Camelopardalis. It's not one star, it's 2. 2 supermassive, hot blue stars in orbit around one another. That alone is not odd. More than half the stars you see in the night sky, if you pull a telescope out on them, what you'll notice is that it's a double or multiple star system. So we're cool with that. What's different here is that these 2 stars are in contact with one another. We are fairly certain that given enough time, these 2 stars will completely coalesce, joining their fuel supplies into one coherent star. What we don't know is, will that star be stable and just join the ranks of other high mass stars that are out there, or will it be unstable and blow itself apart? We don't know. Just keep watching this space. This isn't the only strange binary system to be seen. We're down to number 2. That distinction goes to Gaia 14 AAE. Once again, it's not a single star, it's a binary star system. In this case, one of them is a white dwarf, the end stage of a medium mass star, such as the Sun, and a companion star, which happens to be going through its giant phase. This white dwarf is effectively flaying the outer layers of this giant, consuming it, body and soul. It's basically a stellar cannibal. If the growing mass of the white dwarf crosses a certain threshold, the white dwarf will go unstable and explode, become a supernova. But this isn't even the weirdest thing that can happen when stars collide. And now, the number 1 weirdest star in the Milky Way galaxy. It goes by the name of V Hydra. This star, a red giant star, would not otherwise call attention to itself were it not for every 8.5 years, blobs of nearly 10,000 degree plasma come spewing out at 500,000 miles an hour. Then it stops. 8.5 years later, it repeats. Who ordered that? Our best hypothesis is that this red giant star has a companion, another star in orbit around it that has a highly elliptical orbit, a highly elongated orbit. Spends a lot of time out far away, but when it comes in close, it comes in real close and punches through the physical body of the red giant itself, pops out the other side. And we think that interaction of a hot star and the red giant is what's responsible for spewing forth these blobs of plasma right on schedule every 8.5 years. So we've never seen this phenomenon before. We think we have the right explanation for it, but it remains a unique object in all the star catalogs that we've accumulated. And for that reason, it is the weirdest star in the Milky Way.
And if you want to see some of Neil's top 5 stars for yourself, Peter's here to show you how to find them.
When you look up at the night sky, all of the stars you can see individually belong to our own Milky Way galaxy. Now, in the wintertime, the dense part of the Milky Way, which is towards the core, isn't visible. But when we look up at the sky in the wintertime, we're looking outward in the opposite direction. But this is also a great time to look for some of the 5 must-see stars in the sky. Now, I'm going to start with Omicron Ceti, which is in the constellation of Cetus, the whale or sea monster.
This is the comet-like star, which when viewed in ultraviolet is seen leaving a tail behind it as it races through the galaxy.
Now, this is a variable star, and at its brightest, it's an easy thing to see with the naked eye. But at its dimmest, as it is now, you need a telescope or a pair of binoculars to pick it out. Now, I'm going to use my camera and see if I can take a photograph of the star.
To find it, first identify the Great Square of Pegasus, and then below and to the left, find the faint V-shaped string of stars of Pisces. The string comes to a sharp point at the star Alresha, and this acts like an arrow pointing directly to Omicron Ceti, also called Mira.
I'm actually finding it quite tricky to locate the field where Mira is at the moment. And the reason for that is that there is a full moon coming up, and that's making the sky really bright and drowning out all the faint stars. But I think I'm more or less in the right area now. And I think I've got it. There are 2 stars very close to one another. One of them is red, and that is Omicron Ceti, or Mira as it's known. And it's red because it's a red giant star. Now, I can't see the tail because that's visible in UV light, and UV light is blocked by the atmosphere, so that's best left to the space telescopes. But I've definitely got it, so I'm happy. And in the faint constellation of Camelopardalis, which lies to the north of Auriga and Perseus, is the merging binary star MY Camelopardalis. Now, this is so far north in the sky that from the United Kingdom it never sets, but you will need a telescope to see it.
The best way to find it is to extend a line from the famous eclipsing binary star Algol through Murphak, the 2 brighter stars in the constellation of Perseus. Extend the line they make north for the same distance again, and you'll be in the right area.
And if you're willing to stay up until the early hours, then you stand a chance of seeing the #1 strangest star in the galaxy, V Hydrae, the star system emitting the plasma balls.
It lies in the belly of Hydra the water snake. Halfway along the snake, find New Hydrae, and 5 degrees below that, at the bottom of a Y-shaped pattern of stars, is V Hydrae. A telescope is the best way to see it. But sadly, the last 2 of Neil's favourite stars are too tricky to see. SAO 206462, the star with the spiral arms, is too far south to be seen from the UK. And Gaia 14 AAE, the cannibal binary system, is extremely faint, so would be very hard to spot without a large telescope. This time of year is also great for seeing another of the stellar highlights featured earlier, the Hyades star cluster, which Gaia has mapped in 3D and which can even be seen with the naked eye.
Now, the best way to see them is to use a pair of binoculars or a telescope. And if you use such an instrument, you'll see them in far greater detail. Now, I'm going to take a photograph to see what I can get.
The easiest way to find the Hyades is to extend the line made by Orion's belt up to the northwest, or up and right as seen from the UK, until you arrive at the bright orange star Aldebaran, which is part of the V-shaped face of Taurus the Bull.
So the face of Taurus the Bull is the Hyades, and the Hyades are about 625 million years old, so they're getting to the end of their life. So there are lots of red giants and white dwarfs in this cluster.
Our understanding of the Milky Way is improving all the time. Not only do we now have Gaia's billion-star map, but recently ground-based telescopes have created the most comprehensive map ever made of the distribution of dust in the galaxy. It shows the spiral arms, star-forming regions, and streams of dust. But beyond the stars and dust, there are other parts of the galaxy that we still know extremely little about. The final part of our guide to the galaxy takes us to one of the Milky Way's most mysterious and interesting regions, its outer reaches. It's long been thought that the visible disk of the galaxy is embedded in a huge corona, a vast cloud of hot, ionized gas, and if it's there, it might help us solve a problem. Because when you add up all the dust, all the gas, and all the stars in the disk, all the normal matter, you find there's only about half as much as there should be. And it may be that that missing mass is hiding in the corona. But we know very little about this strange enigmatic region, but scientists here have made a new discovery. Maggie went to meet Dennis Urkel to find out what this discovery can tell us about the nature of the corona and the missing matter in our galaxy.
So Dennis, thank you for coming up to speak to us. And this is a glorious picture. What are we seeing here?
This is a picture that I took in Chile. So this is the night sky as seen from Chile. So this is the Milky Way right here. This is the disk of the Milky Way. And these are the objects we're interested in. This is the Small and Large Magellanic Cloud. These are two dwarf galaxies that very recently they had their closest approach to the Milky Way.
These can only be seen from the southern hemisphere.
These can only be seen from relatively far south.
So what have you discovered so far?
So let's just zoom in a little bit. So this is another picture of the Large Magellanic Cloud and the Small Magellanic Cloud. This was the optical image, but we can also show what happens when we overlay data from a radio telescope. So this shows hydrogen around the Large and the Small Magellanic Cloud. So what we believe happened was, about a few 100 million years ago, the Small Magellanic Cloud passed near the Large Magellanic Cloud. And as it passed nearby, the gravitational force from the Large Magellanic Cloud shredded part of the Small Magellanic Cloud, ripping off this gas bridge.
Oh, wow.
And so now we can overlay this blue line, which just shows us the densest part of the gas. So we've known about this gas bridge for a long time, but what we found recently was a stellar bridge. And so this shows the data from the Gaia satellite. So here, the background image is the one I showed you before, and in white, this milky cloud shows the stars from Gaia smoothed over to make an artist's impression of the data.
Okay, so Gaia has discovered these stars, and it looks like, yeah, there's a stellar bridge, a bridge of stars.
That's right. So this is the stellar bridge coming down here. So just like the gas was ripped off from the Small Magellanic Cloud, we think at the same time stars were ripped off.
So the gas and the star bridge were created at the same time and place. But there's a mystery. Because today, when the images are overlaid, you can see that the two bridges are no longer aligned. And Dennis believes the explanation for this discrepancy is the corona.
So the Large and Small Magellanic Cloud are both moving down roughly in this direction. So we think as they move through the corona, what happens is the gas gets pushed back by the corona from the Milky Way. The stars also feel that pressure from the corona, but since they're small and dense, they basically punch through the corona, so they don't get pushed back at all.
So this result is really good evidence that the corona actually exists.
That's right. There was some evidence before, but we think this adds even stronger evidence, so we're very convinced that the corona is there.
How far does it extend from our galaxy?
We think it extends out to at least 600,000 light years from the center of our galaxy.
Wow. But that's sort of well on its way to Andromeda, isn't it?
That's right. That's about a third of the way to Andromeda, so it's really far out. Wow. And it goes at least that far, we think.
So with this massive corona around our galaxy, can that help account for the missing visible matter in our galaxy?
Yes, we think that this corona can account for a significant fraction of the missing normal matter around our galaxy.
Wow, that's quite a result, isn't it?
Yeah, it's pretty exciting.
There's another layer of significance to this finding, because there's evidence of a similar corona of hot gas around our neighbouring galaxy, Andromeda. Andromeda is about 2.5 million light years away. but it's on a collision course with the Milky Way. We've measured that Andromeda has a corona, and it extends halfway to our galaxy. And now we're getting this strong evidence that we've got a corona that extends a long way. Is there a possibility they could be touching?
That's right, it is very possible. From our models, we think it's very likely that the very outer extents of our galaxy and Andromeda are touching right now.
So I've often heard it quoted that in 4 or 5 billion years' time, the Milky Way and Andromeda will collide. But it sounds as if the collision's already begun.
In a way it has, yes, but these are just the very outer tenuous edges of the coronas of the Milky Way and Andromeda. But yes, the collision is starting to start now.
Well, I think that's pretty exciting. Thank you so much for coming in and talking to us.
Thanks, it's been a pleasure. Thank you.
Thank you.
The collision of the Milky Way and Andromeda will eventually create a new giant galaxy. It's extraordinary to think that the first contact between the two galaxies may have already begun, but it'll be another 4 billion years or so before the merger is complete. It turns out that this intergalactic collision will not be a new experience for the Milky Way, because Gaia has revealed that our galaxy is the product of many previous smaller galactic mergers. The main disk of the galaxy is surrounded by a halo of stars and clusters which live both above and below the disk like this. But what's new is that thanks to Gaia, we can work out how this whole system is moving. Now, the disk is rotating. We've known that for a long while, so it's spinning in this sort of direction. But what Gaia has found is that some of these clusters are moving through the disk, and they're doing so in the opposite direction to the rotation of the disk itself. And so what that means is that these clusters are the remnants of galaxies which our Milky Way has accreted. Our galaxy is growing through galactic cannibalism. And this process is still going on. The Magellanic Clouds Dennis was talking to Maggie about earlier will almost certainly be eaten in the next few 100 million years.
That's it for now from our Guide to the Galaxy. But don't forget, our understanding of the Milky Way is undergoing a revolution. So tune in a year or so's time when we get the next batch of data from Gaia.
Next month, we have a special programme. We'll be taking over some of the telescopes under the clear skies of La Palma in the Canary Islands.
And we want you to tell us what we should point the telescopes at. Find out more on our website, and then email or tweet your suggestions to the usual addresses on the screen now.
And don't forget, you can already check out our star guide on the website.
In the meantime, get outside and get looking up.
Good night.
Sexual obsession, art and power coming up on BBC4. Stay with us for an intriguing battle of the sexes with Roman Polanski's Venus in Fur next.